Good evening, scholars. Our lesson for this evening is how to use data to solve for molecular formulas. Before I show you how to solve the word problems, let's review a little bit about the difference between molecular and empirical formulas. Recall from our previous lesson that the molecular formula is the actual number of atoms in a compound, whereas the empirical formula is a ratio of atoms in the compound. And another way you can distinguish it from the molecular formula is that the empirical formula is a reduced form of the actual chemical formula. In the example that I have here, C6H12O6 is the molecular formula of glucose. Now, to convert this molecular formula into its empirical formula, we simply need to reduce it, and we do so by dividing by a factor of 6. Now, if I know the empirical formula and I want to convert it back into its molecular formula, all I have to do is go in reverse. Instead of reducing, I need to multiply by the same factor I used to reduce it into its empirical formula. So when CH2O is multiplied by 6, I get C6H12O6, which is the molecular formula of glucose. So I can always get the molecular formula if I know the factor to multiply my empirical formula by. This factor or multiple we'll call N can be experimentally found by dividing the molar mass of the compound by the molar mass of the empirical formula. So with this information in hand, let's work through our first example. It says a compound with a molar mass of 58.12 grams per mole was found to contain 82.68% carbon and 17.32% hydrogen by mass. What is the molecular formula of the compound? So in step 1, we need to make sure that we find the empirical formula of the compound if it's not already given to us. Once we've found our empirical formula, our next step is to find the molar mass of this empirical formula. In our next step, we want to take the molar mass of the compound, which is 58.12 grams per mole, and divide that by the molar mass of our empirical formula. This will be equal to our multiple that we need in order to find the molecular formula. So 58.12 divided by 29.06 gives us a multiple or factor of 2. In our last step, we are going to take this multiple of 2 and we're going to multiply it against the empirical formula, and that will give us a molecular formula of C4H10. In our second and last example, it says butylene has an empirical formula of CH2 and a molar mass of 56.10 grams per mole. What is the molecular formula of butylene? Since our empirical formula is already given to us, our next step is to find the molar mass of the empirical formula. And here we see that the molar mass of the empirical formula is 14.03 grams per mole. In our next step, we want to take the molar mass of our compound, which is 56.10 grams per mole, and we want to divide that by the molar mass of our empirical formula, which is 14.03. This will give us our factor or multiple used to find the molecular formula. 56.10 divided by 14.03 gives us a multiple of 4. In our last step, we're going to take our empirical formula and we're going to multiply it by 4. And when one carbon and 2 hydrogens are multiplied by 4, I get as a molecular formula for butylene as C4H8. Okay, that wraps up tonight's lesson. For my internet viewers, if you have any questions, send me a message at my YouTube channel. For my students, write down any questions you have and bring them to class. Thank you for watching and have a great day.